Hello and welcome everyone. So I'll be explaining a very good greedy problem named B.Vova and trophies, taken from recent educational around 55. Okay, so the statement actually says that you're given an n-length string consisting of only two characters, respectively they are golden or silver. Now you have to tell the maximum possible beauty of the arrangement if okay, you need to actually find out the maximum possible beauty. And what is the beauty of the arrangement? It is actually the length of the longest subsegment consisting of golden trophies, which means indicating the G character. And also you're mentioned here that you can um, you can you can apply one operation at most one time. Okay, you can apply an operation at most one time, which is you can actually swap two characters. It doesn't matter whether it's adjacent or not. Okay, you can swap any two characters you want. And what's most interesting is that there are only two characters, right? So which is either G or S. Now it's a pretty common intuitive approach that you will always use that swap operation if there exists any S here with G, and you will also always do the swap operation with uh, between two different characters which are respectively G and S, which is golden and silver indicating. Now how should we build up this problem? As you can see, we only have two characters, right? We only have two characters, which means um, we can make some kind of group. One group will consist of um, only golden characters, okay, which means the G characters, and the other group would consist of the silver one. Let's say we have G, 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 S, 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 G, G, S. So what will be our general approach? Our general approach would be to divide while traversing. We will make some groups of G and S. Now how we're going to be making the groups? We're going to be making consisting elements of G's group and also consisting silver characters group. So by applying this we can make a group like this, okay, consisting G, that we could call a group G. Now this is also another group that we can define, which is group of S and also group of G, okay, and here also group of S. Now as the question it is mentioned that we have to find the maximum beauty of the string, right? So we will only care about the group of G. We'll only care about the group of G because we need to find out and make the maximum consecutive golden characters. So we will always take care of our golden group. How many golden groups we have, we need to somehow track it. Now how is this going to help us? This is going to help us because if we somehow track our golden groups, and if we somehow track our golden groups first and last index, okay, this is first and last index, we will see that we can make, okay, we can only what could be the optimal approach if, let's say, we have more than, let's say, for general purpose, let's say we have two groups of G, okay. Now if there are two groups of G, we will try to find out if there are any other characters, which means if there are any silvers between them. Of course, there will always be any silver because there are two groups, right? So we will try to find out what are the in between characters, how many characters of silver are there. Now if that number, okay, between two groups, if that silver characters number is 1, okay, not greater than 1 but 1, then we can always make an optimal answer. How? And if it does not, let's say, let's take an example. We will understand it better. Now let's take G, and we have one S here. And remember what we said, we're only now dealing with two golden groups. Now we have one group here and we have one group here, and what we said, let's say some S's are displaying here, it doesn't matter. Now look, there's only one S between these two groups, not two, not three, only one. Now how can we do the swap operation to make it make the result as optimal as possible? We can do this. How? If I swap this S with this G, or maybe this G, it doesn't matter which G. If I swap, let's say I'm swapping with this G, what happens is this G comes here, becomes G, and this G becomes S. And by doing that operation, we actually improved our result from the previous, right? So then our maximum result would be, our optimal result would be 1 2 3 4 5 6. Okay, that would be our optimal result. And what if this happens? Let's say we have only two groups. I'm only talking about two groups, right? If and also one thing to notice is that if we have only one group of G, then this will then obviously that would be the answer. The count of that group members would be the answer. That's obvious because there we have only got one group. Now what we were talking about two golden groups. Now what if this sort of case occurs? Let's say S, okay, and okay, so what we have here, we have two groups of golden, okay, two golden groups. One has the member of 3 golden and the other one has 4 members, and it is 3. Now if you slightly analyze, we don't have one silver between those two groups. We have greater than 1. Now in this situation, what we have to do is we have to find out the optimal approach. How can we find the optimal approach? Our first task would be to determine which is the maximum which group has the maximum member of golden. Now if we if we analyze it, we will find out that this group of golden has the maximum members, which is 4, right? Now how is this going to help us? This is going to help us because our optimal answer would be, we will take this G here, okay? We will take this G here and we will swap it with this S, this silver, which is exactly close to our larger member of golden group, and we're going to be swapping this. If we swap this between these two characters, what happens is this becomes G and this becomes S. And finally we also found out a way to improve our result of beautifying the result, and our answer becomes 1 2 3 4 5. 1 2 3 4 5. Okay, the beauty of the string then also increased to 5 by doing this. What if we did this operation reversely, which means what if we swapped this G, what if we swap this S with this G? What would happen then? then we would not have got the optimal result that would give us 4. What if we did this? Let's take another example. What if we did G, G, S, S, G, G? Now, let's say 1S also. So this won't give us optimal result too by swapping this S with this G. If I say here G and here S, this would not have given us. Okay, so when will we do this? When will we insert G in between those two groups? Only when there are only one silver left between the two groups. Then we will try to maximize the result. Now, these are all the cases that we need to take care of when there are one groups and two groups. Now, what will be the general approach, which is if there are groups greater than or equal to 3. Now, let's generalize this. Let's say we have group of G here. We have group of S. And we have group of G, group of S, and group of G. Okay. Also group of S. So we have what? More than two groups. When we have more than two groups, what we will do is we are guaranteed that our initial answer could be what is the maximum consecutive golden yet. I'm not saying for sure, I'm saying could be, right? This is my initial maximum. Why is it I'm saying? Because look, as there are more than 3 groups, we can easily define that yes, I will always get some answer. Let's say initially I will find my maximum as the maximum consecutive golden characters available. And why I'm adding this one? Because I am fully sure that if I somehow do not get any between the two groups silver characters more not equal to 1, if I don't somehow get that, I can always make one silver character and make it and increase to my maximum consecutive. It's always possible. Let's take it's always possible. So that's why we're going to be initializing our maximum as maximum plus 1, because we can always find something. If let's say I cannot find any optimal result, I cannot add my two groups or something like that, then the answer will always be our maximum consecutive golden characters plus 1. Why is 1? Because we can always swap some silver to we can always swap our maximum consecutive golden's immediate adjacent silver to any other group's golden. That's why initial maximum is this. Now, what we have to do is we will check like this whether this group and this group's, we will try to find out what is the in between two groups. Consecutively, we will try to traverse those groups one by one and trying to find out what are the in between silver members. If it is equal to 1, then there is a chance that I can optimize the result. Now, what will be the optimized result now? Remember, it's going to be different from when we talked about if we had two groups of golden. Why it's going to be different? It's going to be a little bit of different, but quite same as the things that we talked recently. Okay, now what we have to do is, let's say we have found out that this number of s is 1. Okay, here number of S is 1. So we have already found out what is our optimal result, right? Now what could be the optimal result? Now we will say that, okay, my temp variable will consist of, let me show you what we will write here. We will write, okay, I can make it, I can make some golden here. Now which golden I'm talking about now, because I have already greater than or equal to 3 groups of golden. Now I can always take one golden apart from these two which are adjacent to these silver, right? So we will to increase the optimality, we will do is we will swap this S with what? Another group's G. Yes, you've got that right. Another group's G, we will swap it. Because we always, in this way, we don't even have to swap with any of these goldens. We already have greater than or equal to 3 groups of golden, so we can always choose to make and swap it, this silver with this golden. And then just for this purpose, we have to add an extra 1. Okay, so that's extra 1 plus the length of this group plus the length of this group. This part is actually very similar to the part that I talked about previously when we had only 2 groups of golden characters. Now, as there are greater than or equal to 3 golden character groups, okay, so we can always pick some other golden group's character and swap it in between this one silver. Remember, if it's not equal to 1, if this part silver member is not equal to 1, then we cannot do that, right? Then our answer will go down to only that. So I hope I made you understand. Now we are going to be checking out the code part for more clarification. So here what we did was we took a vector of pair, we took our, and we were traversing our string. If we somehow found out the golden part, then we are actually here, this part is actually taking care of the index. So each and every golden group's first index, this is indicating the first index, and this is indicating blank because I haven't yet got my ending index of my any golden groups. Here I'm doing that part. Okay, I'm inserting the ending index of my golden group. So that's how that's why I have taken a pair vector to collect all those golden groups of first and last index. Now then after that what we did was uh, for length 1, which if length is equal to 0, then answer is 0. If length is equal to 1, then answer is already max, because we have found out that this max is our answer, will always be, because if length is 1, then absolutely here we actually tried to find out the maximum consecutive golden characters. And then here, if length is equal to 2, what we said, we will try to look if in between, now why am I doing this if it's not equal to 2? If it's not equal to 2, now why is this 2? Because, let me show you here. Let's say our one group is here, 1 at index 1, and the other group is index 3. Other group starts from here, and in between, in this index, 1 silver is there. So how do we check that whether there is 1 silver or not? By doing the subtraction. So if I do 3 minus 1, it will become 2. So I'm just checking this whether there are only 1 silver or not. If it's not, then the answer would always be maximum plus 1, because I can always choose something. And if it is equal to 2, then we can find our maximum result, which is what? This adding those 2 groups is length. And if the total group number is always greater than or equal to 3, then we always have our initial answer as maximum plus 1. Otherwise, if we can somehow optimize, if our condition meets successfully, when we subtract our operations and it becomes equal to 2, I showed you why it's 2. We are actually checking whether there are one silver between those two groups or not. And finally, this is the part same as the previous one, and this one extra one will be added, which will be from another golden group's character. So that's how we're going to be finding out our maximum values, and each time I'm actually doing the maximum, because you never know when one becomes maximum and when one becomes minimum. So that's how I actually did that, and it finally got accepted here. So that's it then. So I hope I made you understand. Till next time, good.